A greenhouse is a structure with walls and roof made chiefly of transparent material, such as glass, in which plants requiring regulated climatic conditions are grown. These structures range in size from small sheds to industrial-sized buildings. A miniature greenhouse is known as a cold frame. The interior of a greenhouse exposed to sunlight becomes significantly warmer than the external ambient temperature, protecting its contents in cold weather. Many commercial glass greenhouses or hothouses are high-tech production facilities for vegetables or flowers. The glass greenhouses are filled with equipment including screening installations, heating, cooling, lighting, and may be controlled by a computer to optimize conditions for plant growth. How greenhouses work. The explanation given in most sources for the warmer temperature in a greenhouse is that incident solar radiation passes through the glass roof and walls and is absorbed by the floor, earth, and contents, which become warmer and re-emit the energy as longer wavelength infrared radiation. Glass and other materials used for greenhouse walls do not transmit infrared radiation, so the infrared cannot escape via radiative transfer. As the structure is not open to the atmosphere, heat also cannot escape via convection, so the temperature inside the greenhouse rises. This is known as the greenhouse effect. The greenhouse effect, due to infrared opaque greenhouse gases, including carbon dioxide and methane instead of glass, also affects the Earth as a whole. There is no convective cooling as air does not escape from the Earth. However, W. Wood in 1909 constructed two greenhouses, one with glass as the transparent material, and the other with panes of rock salt, which is transparent to infrared. The two greenhouses warmed to similar temperatures, suggesting that an actual greenhouse is warmer not because of the greenhouse effect, as described in the previous paragraph, but by preventing convective cooling, not allowing warmed air to escape. More recent quantitative studies suggest that the effect of infrared radiative cooling is not negligibly small, and may have economic implications in a heated greenhouse. Analysis of issues of near-infrared radiation in a greenhouse with screens of a high coefficient of reflection concluded that installation of such screens reduce heat demand by about 8%. And application of dyes to transparent surfaces was suggested. Composite less reflective glass, or less effective but cheaper anti-reflective coated simple glass, also produced savings. Types. Greenhouses can be divided into glass greenhouses and plastic greenhouses. In domestic greenhouses, the glass used is typically 3 mm horticultural glass grade, which is good quality glass that should not contain air bubbles. Plastics mostly used are polyethylene film and multi-wall sheets of polycarbonate material, or PMMA acrylic glass. Commercial glass greenhouses are often high-tech production facilities for vegetables or flowers. The glass greenhouses are filled with equipment such as screening installations, heating, cooling and lighting, and may be automatically controlled by a computer. Dutch light. In the UK and other northern European countries, a pane of horticultural glass referred to as Dutch light was historically used as a standard unit of construction, having dimensions of 28 3/4 x 56. This size gives a larger glaze area when compared with using smaller panes such as the 600 mm width typically used in modern domestic designs, which then require more supporting framework for a given overall greenhouse size. A style of greenhouse having sloped sides and using these panes uncut is also often referred to as of Dutch light design, and a cold frame using a full or half pane as being of Dutch or half Dutch size. Uses. Greenhouses allow for greater control over the growing environment of plants. Depending upon the technical specification of a greenhouse, key factors which may be controlled include temperature, levels of light and shade, irrigation, fertilizer application, and atmospheric humidity. Greenhouses may be used to overcome shortcomings in the growing qualities of a piece of land, such as a short growing season or poor light levels. and they can thereby improve food production in marginal environments, as they may enable certain crops to be grown throughout the year. Greenhouses are increasingly important in the food supply of high-latitude countries. One of the largest complexes in the world is in Almería, Andalusia, Spain, where greenhouses cover almost 200 square kilometers. Greenhouses are often used for growing flowers, vegetables, fruits, and transplants. Special greenhouse varieties of certain crops, such as tomatoes, are generally used for commercial production. Many vegetables and flowers can be grown in greenhouses in late winter and early spring, and then transplanted outside as the weather warms. Bumblebees are the pollinators of choice for most pollination, although other types of bees have been used, as well as artificial pollination. Hydroponics can be used to make the most use of the interior space. The relatively closed environment of a greenhouse has its own unique management requirements, compared with outdoor production. Pests and diseases, and extremes of heat and humidity, have to be controlled, and irrigation is necessary to provide water. Most greenhouses use sprinklers or drip lines. Significant inputs of heat and light may be required, particularly with winter production of warm weather vegetables. Greenhouses also have applications outside of the agriculture industry. Glass Point Solar, located in Fremont, California, encloses solar fields in greenhouses to produce steam for solar-enhanced oil recovery. Alpine House is a specialized greenhouse used for growing alpine plants. The purpose of an alpine house is to mimic the conditions in which alpine plants grow, particularly to provide protection from wet conditions in winter. Alpine houses are often unheated, since the plants grown there are hardy, or require at most protection from hard frost in the winter. They are designed to have excellent ventilation. History. The idea of growing plants in environmentally controlled areas has existed since Roman times. The Roman Emperor Tiberius ate a cucumber-like vegetable daily. The Roman gardeners used artificial methods of growing to have it available for his table every day of the year. Cucumbers were planted in wheeled carts which were put in the sun daily, then taken inside to keep them warm at night. The cucumbers were stored under frames or in cucumber houses glazed with either oiled cloth known as specularia or with sheets of selenite. According to the description by Pliny the Elder, in the 13th century, greenhouses were built in Italy to house the exotic plants that explorers brought back from the tropics. They were originally called giardini botanici, active greenhouses, in which it is possible for the temperature to be increased or decreased manually, appeared much later. Sanga Yorok, written in the year 1450 AD in Korea, contained descriptions of a greenhouse which was designed to regulate the temperature and humidity requirements of plants and crops. One of the earliest records of the annals of the Joseon dynasty in 1438 confirms growing mandarin trees in a Korean traditional greenhouse during the winter and installing a heating system of ondol. The concept of greenhouses also appeared in the Netherlands and then England in the 17th century, along with the plants. Some of these early attempts required enormous amounts of work to close up at night or to winterize. There were serious problems with providing adequate and balanced heat in these early greenhouses. Today, the Netherlands has many of the largest greenhouses in the world, some of them so vast that they are able to produce millions of vegetables every year. The French botanist Charles-Lucien Bonaparte is often credited with building the first practical modern greenhouse in Leiden, Holland, during the 1800s to grow medicinal tropical plants. Originally only on the estates of the rich, the growth of the science of botany caused greenhouses to spread to the universities. The French called their first greenhouses orangeries, since they were used to protect orange trees from freezing. As pineapples became popular, pineries, or pineapple pits, were built. Experimentation with the design of greenhouses continued during the 17th century in Europe. As technology produced better glass and construction techniques improved, The greenhouse at the Palace of Versailles was an example of their size and elaborateness. It was more than 150 meters long, 13 meters wide, and 14 meters high. The golden era of the greenhouse was in England during the Victorian era, where the largest glass houses yet conceived were constructed, as the wealthy upper class and aspiring botanists competed to build the most elaborate buildings. A good example of this trend is the pioneering Kew Gardens. Joseph Paxton, who had experimented with glass and iron in the creation of large greenhouses as the head gardener at Chatsworth in Derbyshire, working for the Duke of Devonshire, designed and built the Crystal Palace in London. Other large greenhouses built in the 19th century included the New York Crystal Palace, Munich's Glaspalast, and the royal greenhouses of Laeken for King Leopold II of Belgium. In Japan, the first greenhouse was built in 1880 by Samuel Cocking, a British merchant who exported herbs. In the 20th century, the geodesic dome was added to the many types of greenhouses. Notable examples are the Eden Project in Cornwall, the Rodale Institute in Pennsylvania, the Climatron at the Missouri Botanical Garden in St. Louis, Missouri, and Toyota Motor Manufacturing, Kentucky. Greenhouse structures adapted in the 1960s when wider sheets of polyethylene film became widely available. Hoop houses were made by several companies and were also frequently made by the growers themselves. Constructed of aluminum extrusions, special galvanized steel tubing, or even just lengths of steel or PVC water pipe, construction costs were greatly reduced. This resulted in many more greenhouses being constructed on smaller farms and garden centers. Polyethylene film durability increased greatly when more effective UV inhibitors were developed and added in the 1970s. These extended the usable life of the film from 1 or 2 years up to 3 and eventually 4 or more years. Gutter-connected greenhouses became more prevalent in the 1980s and 1990s. These greenhouses have 2 or more bays connected by a common wall, or row of support posts. Heating inputs were reduced as the ratio of floor area to roof area was increased substantially. Gutter-connected greenhouses are now commonly used both in production and in situations where plants are grown and sold to the public as well. Gutter-connected greenhouses are commonly covered with structured polycarbonate materials, or a double layer of polyethylene film with air blown between to provide increased heating efficiencies. A plastic air-insulated greenhouse in New Zealand. Giant greenhouses in the Netherlands. The Netherlands has some of the largest greenhouses in the world. Such is the scale of food production in the country that in 2000, greenhouses occupied 10,526 hectares, or 0.25% of the total land area. Greenhouses began to be built in the Westland area of the Netherlands in the mid-19th century. The addition of sand to bogs and clay soil created fertile soil for agriculture, and around 1850, grapes were grown in the first greenhouses. Simple glass constructions with one of the sides consisting of a solid wall. By the early 20th century, greenhouses began to be constructed with all sides built using glass, and they began to be heated. This also allowed for the production of fruits and vegetables that did not ordinarily grow in the area. Today, the Westland and the area around Aalsmeer have the highest concentration of greenhouse agriculture in the world. The Westland produces mostly vegetables, besides plants and flowers. Myrno-Gladst is noted mainly for the production of flowers and potted plants. Since the 20th century, the area around Venlo and parts of Drenthe have also become important regions for greenhouse agriculture. Since 2000, technical innovations include the closed greenhouse, a completely closed system allowing the grower complete control over the growing process while using less energy. Floating greenhouses are used in watery areas of the country. The Netherlands has around 4,000 greenhouse enterprises that operate over 9,000 hectares of greenhouses and employ some 150,000 workers. efficiently producing €7.2 billion worth of vegetables, fruit, plants, and flowers, some 80% of which is exported. Greenhouse ventilation. Ventilation is one of the most important components in a successful greenhouse. If there is no proper ventilation, greenhouses and the growing plants can become prone to problems. The main purposes of ventilation are to regulate the temperature and humidity to the optimal level, and to ensure movement of air and thus prevent build-up of plant pathogens that prefer still air conditions. Ventilation also ensures a supply of fresh air for photosynthesis and plant respiration, and may enable important pollinators to access the greenhouse crop. Ventilation can be achieved via use of vents, often controlled automatically via a computer, and recirculation fans. Greenhouse heating. Heating or electricity is one of the most considerable costs in the operation of greenhouses across the globe, especially in colder climates. The main problem with heating a greenhouse as opposed to a building that has solid opaque walls is the amount of heat lost through the greenhouse covering. Since the coverings need to allow light to filter into the structure, they conversely cannot insulate very well, with traditional plastic greenhouse coverings having an R value of around 2. A great amount of money is therefore spent to continually replace the heat lost. Most greenhouses, when supplemental heat is needed, use natural gas or electric furnaces. Passive heating methods exist which seek heat using low energy input. Solar energy can be captured from periods of relative abundance, and released to boost the temperature during killer periods. Waste heat from livestock can also be used to heat greenhouses, e.g., placing a chicken coop inside a greenhouse recovers the heat generated by the chickens, which would otherwise be wasted. Electronic controllers are often used to monitor the temperature and adjust the furnace operation to the conditions. This can be as simple as a basic thermostat, but can be more complicated in larger greenhouse operations. Greenhouse carbon dioxide enrichment. The possibility of using carbon dioxide enrichment in greenhouse cultivation to enhance plant growth has been known for nearly 100 years. After the development of equipment for the controlled serial enrichment of carbon dioxide, the technique was established on a broad scale in the Netherlands. Secondary metabolites, e.g., cardiac glycosides in Digitalis lanata, are produced in higher amounts by greenhouse cultivation at enhanced temperature and at enhanced carbon dioxide concentration. Commercial greenhouses are now frequently located near appropriate industrial facilities for mutual benefit. For example, Cornaway's nursery in the UK is strategically placed near a major sugar refinery, consuming both waste heat and CO2 from the refinery which would otherwise be vented to atmosphere. The refinery reduces its carbon emissions, whilst the nursery enjoys boosted tomato yields and does not need to provide its own greenhouse heating. Enrichment only becomes effective where, by Liebig's law, carbon dioxide has become the limiting factor. In a controlled greenhouse, irrigation may be trivial, and soils may be fertile by default. In less controlled gardens and open fields, rising CO2 levels only increase primary production to the point of soil depletion, as demonstrated prima facie by CO2 levels continuing to rise. In addition, laboratory experiments, free air carbon enrichment test plots, and field measurements provide replicability.